Okay, so this video is focusing on chapter 8a, and it's just looking at one of the questions in the textbook number 2, which is one of the complex familiar ones. Question 3, 4 and 5 are very similar, so it might be worthwhile watching this video and then going to attempt those on your own or using this as a reference tool. So, looking at the question, it says a reducing balance loan can be modelled by the recurrence relationship of the starting value of 2,500, where the recurrence relation is 1.08 multiplied by the previous balance minus 600. Now the first question asks, what is the value of the repayment for each compounding period? What we'd be looking at in this question is we'd be flipping back to those examples and thinking, well, hold on, there's a relationship with this formula. It looks like one that I used to work out how much is left on a loan. This value here would be our capital R value, which is our repayment. So the first one's quite simple. Our repayment amount would be $600. And we know that by relating it to a formula that we're already aware of. Pardon me. Number B says use calculator recursion to determine how much is still owed on the loan after 3 repayments have been made. So we need to use this formula to work out how much is owing after 3 payments. So realistically, I'm going to have A1, A2 and A3. Now I'd be using the same formula for each, so 1.08 times AN take 600, similar here and similar here. The only thing that will be changing for each of them is I'll be changing this AN value. So to work out my starting one, I'm going to be using the amount that I'm initially investing. So 2,500 minus 600. So when I go to enter that into my calculator, 1.08 times 2,500 take 600 is 2,100. So that's how much I owe after 1 payment. We want it for 3, so I need to do it 1 more time, or 2 more times actually. The only thing that changes for this one is I'm substituting 2,100 into that A to the N section. So when I go to put this in, I'm just going to move this part over so I have a little bit more room. It's going to be 1.08 times this value, so 2,100 minus 600. So again, if I go to put this into my calculator, I get 1,668. So that's after 2 payments. Still need to do it once more. So similar thing, 1.08 multiplied by my previous value. Oops. It's going to be a minus sign, so minus 600. So again, I'm going to put that into my calculator. Ooh, that's not right. Take away 600. Put in 60, not 600. Sorry guys. And I get 1,201.44. So my answer to B, after 3 payments, using this relationship, payment 1, payment 2, payment 3, is $1,201.44. The final part of this question, how much interest has been paid after the 3 repayments? So this question's really scaffolded it out for you, because we now have the value that we can substitute into this formula. We use this formula in example 2. It calculates the total interest, where N is the number of compounds, R is the repayment value, A to the O is our starting term, A to the N is the balance of the previous payment. So, although we're not told how many compounds there are, we know that there were 3 payments. So this is going to be 3 times our repayment amount of 600, which we worked out at the very start of the question. So that's where this textbook is helping us out. Our starting term minus the balance we know. So I'm just going to put a little arrow because we worked that out. So this is the amount we owe after 3 years. Now I'm going to go put this all into my formula. And I get $501.44. So that's how much interest we pay. Now what we need to think about with this question is it's complex familiar. So it's complex, there's a lot of steps, but it's familiar because it's using formulas we know. If I wanted to really shorten this question, I could say using this relationship, how much interest do I pay over 3 years? So I'm asking the same question, I'm just not including these two scaffolding steps. So be aware in the textbook, if they do shorten it like that, it might be that you've just got to implement steps like this in the middle of it. Have an attempt at 3, 4 and 5. They're very similar. They're a really good way to practice. Thank you. Okay, so this video is looking at question 6 of chapter 8a. It's a complex unfamiliar question. There is only one complex unfamiliar question in this chapter. So instead of me fully completing the problem, what I think I might do is give you some hints and tips to get you going. But if you do get really stuck, please email me. So, question 6. What it says is that Andrea needs to borrow $20,000. Her bank will charge interest at an annual percentage interest rate of 7.0%, compounding monthly. Andrea will be required to make monthly payments of $600, but Andrea thinks she can afford to pay $800. For part A, construct a recurrence relation for monthly payments of $600. For part B, construct them for repayments of $800. And then it wants you to have a look at how much interest she will be saving. So that's where the unfamiliar part comes to it. So first of all, we have to create recurrence relationships for both repayment of $600 and repayment of $800. So I'm doing A and B all together. Okay, first things first, write down what you know. We know that the loan was for $20,000, so that's our starting value. We know that we had an interest rate of 7.08%, so I've written this in its rate form where I'm dividing it by 12 because it's compounding monthly. I've also got the 1 plus in there because I know with our recurrence relationships that needs to be included. So I've also done the calculation for that. So when I divide 0.0708 by 12, I get 0.0059. That's where that relationship comes in. Now I also have a capital R value, 600 for this part, 800 for this part. So let's create a formula or a recurrence relationship. So I know my formulas are going to be very similar in the structure. And the first thing that's going to occur is my rate multiplied by the payment. So it's going to be R times A to the n because it's going to be based off the previous balance. Now in addition to that, I also have to take into account the repayment. So I'm going to have minus capital R. So scaffolds are very similar. Some of the substitutions will be similar too, because we know my rate is going to be the same for both. We also know, at least to start with, the A to the n value will be the same. But for the moment, because this will change, I'm going to keep it as A to the n. Lastly is the repayments. So for A, when the repayment is 600, I'm minusing 600. When it is 800, I'm minusing 800. What the next question is asking us to do is to find the total, how much would Andrea owe after 5 months. So I need to apply this over a 5-month period. Following that, it also wants us to work out the total interest that she pays. So I would have to use the value that I end up with after 5 months and apply it to our interest formula, where we have capital I. So let's just say that's part 1. This will be part 2. So when I go to calculate the interest, I'm going to be using my formula where I'm multiplying the repayments by the number of repayments, and I'm minusing how much I've actually paid. So we've used both of these formula. This one was in example 1, this one was in example 2. So what I'd like to see is you guys have an attempt at applying this. If you do get really stuck, send me an email, but I think this is a really good start that you guys can now have an attempt at the problem. When you get to the last section, in working out how much more interest they save, well, in knowing how much more is us calculating the difference. So essentially, I would be calculating the difference between these two values. So again, this part is just like our hard work, so we can apply the difference in how much we earn.